right, well, thanks for coming. I'm a lucky person to get the early morning spot, so if you're not awake, I'm sorry for waking you up with some horrors from Gradle. Yeah, so if you're here for listening about Gradle, this is the right room. If not, feel free to leave. I'm not going to get offended. Yeah, so let's start talking. So who am I? My name is Aurimas. I've been at Google for 12 years, and 8.5 of those I've been on Android X. Work pretty closely with Android Studio, JetBrains, and Gradle. Fix bugs, collaborate, make features, and so on. So hopefully you can somewhat trust me that I know a little bit what I'm doing. Many of you in this room probably go from an idea to a cool product. You come up with something cool, and then you go and build it. And today I kind of want to delve a little bit into the process of like what does it take to go from an idea to a product. Normally, what you will find is that it's usually not a one-step process. Unless it's like a super trivial project, you're probably going to have to like do it several times. You will have failures, you'll have mismatch of vision, or maybe you'll build something really awesome and you're like, actually, no, that gives me an idea, I should build it better. And this is kind of going to talk a little bit about that. And the process of kind of getting there is iteration. And it's the best way to really get to a product that you want to build. It's slowly getting closer and closer to what you want until you finally get to the thing that you actually want to have in your hands. And faster iteration, research says, not me, that you can either get to the output faster or you can actually get higher quality product depending on how you end up spending your time. So it's not just completely like made up stuff. If you're able to iterate faster, you can get to a better thing in one or another axis. And if you've seen XKCD, right, it's like a meme, right, of like, oh, like my code is compiling, I'm gonna go get a cup of coffee. Like that is a way that jars you away from your work, and you're not in the flow, right? If you're in the flow, you're going, you're doing the thing, you're iterating, and it's almost like how many different evolutions of your thing you get to do in the same amount of time. The faster you can iterate, the more evolved your product will be. And I think it's kind of important to also think about like what is useful work. There's always overhead for any type of project. There's usually preparation and sort of finalization of any project that you do. So if you're doing like a DIY project, you might have to lay out all of your tools, and then at the end of it, you have to put them all away. And for certain tasks, you might have to pick up a tool every time. So if you're like soldering, and you have to pick up the soldering iron every time and put it away, and then the useful part is actually melding the two pieces together, but you end up doing a lot of other stuff that is not like directly quote unquote useful work. And ideally, that iteration loop of like the overhead is zero, right? You spend no time doing other things, you're just doing the thing you want to do, and then you're in the ultimate, this is amazing. And you're like, wait, I thought this was about Gradle. What is he talking about? So now we're jumping into the Gradle part of the things. You might be aware that Gradle has 3 build phases. There is initialization phase, there's configuration phase, and the execution phase. Specifically, the initialization phase is compiling and evaluating settings.gradle. In the simple projects, there's a single one. It builds a list of projects that you have in there. Included builds might have multiple settings.gradle. So this step is essentially take settings.gradle, ask type things, and build a list of projects that are going to be involved in a build. And then the second phase is configuration phase that takes those list of projects and then compiles and evaluates all of build.gradle.kts files. And that builds a list of graphs, a task graph. And this task graph essentially is like, what do you want to do? Like, here's all the possible things you could do, and then here's all the requirements to execute one thing or another. And then finally, there's the execution phase that takes the graph that you built, and then now you actually want to run it. And of course, you have, a constraint of like how many cores you have, and that limits of how many tasks you could execute. You can't possibly, execute all of them at once. And this is the useful part, right? That's the part that you actually want to do. And then everything else is kind of overhead that you really wish you skipped because that will allow you to get to the thing you're trying to do faster. And then one thing what you notice here is, today in Gradle is every time you do anything, you rerun all the phases by default. You do initialization, you do configuration, and you do execution. And even if you don't change your arguments, you're doing the same thing over and over again, like, kind of wasting time of the overhead. And then that's where Gradle jumped in and created a feature because they recognized that there's that repeated work over and over again, and they created a feature called configuration cache. And what it really does, it takes the configuration phase and essentially stores the results of it so you can reuse it next time you call Gradle. And it's controlled by a Gradle property or a command line argument. Property is what you probably want, just put in your Gradle the properties and you're running it. So again, to remind you, there's 3 phases normally by default: initialization, configuration, execution. When you enable configuration cache and you have a first run, this is essentially a miss, you will have an additional step in the process where you will do initialization, configuration, and then there's a step that essentially takes and serializes all of the work that it did in configuration phase and writes it to disk. And then there's also a step that it goes and deserializes that, and we'll talk a little bit about why they do that later, but essentially it stores all of those results. And then what happens then if you have a configuration cache hit, it skips a bunch of work that it would have done in the past, and just deserializes it, loads it from disk, and then it's not evaluating any build.gradle files because it knows you've not modified them. It can just go and start running tasks. So you're essentially cutting that overhead by a drastic amount. And you're like, oh, but I really need this? Like, my project's fine. Like, I don't think I need this. So let's talk. I'm going to give you a couple of hopefully motivating examples that will be like, oh, yeah, maybe I should consider this. So Android X, which is a project I work on, we have 786 Gradle projects. So it's a fairly sizable thing. We have a lot of contributors. So anytime we can cut off of the overhead is useful. It's beneficial. And there are so many tasks in engineering that you do that are like iteration type, where you're doing the thing over and over again until it works, sometimes on purpose, sometimes not. But in this case, like what common thing is to do is you want to fix a bug or a test, you do a piece of that fix, and then you try it again. You do a fix again, and you try again. So in here, if we take our project, you're modifying a single test file, and then you're just running it, and you're repeating it over and over again, right? That's like a fairly common pattern of something someone on your team might do. So as I described before, what you do is, Gradle by default, if you don't have configuration cache on, it will go do the initialization, it will do the configuration phase, it will go through every single project one at a time in serial mode. If you have a large project, the configuration gets longer and longer and longer as you modularize, as you add more projects. And it can become like a real drag, right? Like if you start on a project and you have a single one, you're not gonna notice this. This is like not a problem. But like you get to hundreds, you get to thousands, it becomes a real problem. And I'm like having to fill time to let you see how slow this is, because this is how long it takes in Android X if I turn off configuration cache and I just let it run. And it's like O of N of when you have the thing, right? So it's an extremely long time. We're still waiting, and now here we finished it, right? So if we look at it, it took 44 seconds for us to do this. Actually 42, I lied. And then 40 of them are just overhead. It's just like doing the stuff that you don't actually care about, right? And then if you're iterating, the 40 seconds is a long time. And if you jump to the configuration cache enable, it like drastically cuts the amount of time. I say a couple of sentences and we're done, right? That's 4 seconds. And that means there's like 32 times less overhead. And you can repeat the same work 10 times in the exact same amount of time. So like hopefully that's kind of like, oh yeah, like I can see where he's going with that. Another example is getting parallel tasks within a project. By default, Gradle only runs one task at a time. That's just how it works. You're like, oh wow, that's a crazy decision, but Gradle was created in 2008, and your favorite MacBook Pro back then had 2 cores. So like not doing parallel work, it was not wild back then. But it's true, it's even today, if you pull Gradle and you use default settings, it will run a single task at a time, and that's a problem. And if you have a bunch of tasks that are slow, they will all run serially. So in this example, I created a bunch of tasks that take 5 seconds to run, and it will just do one at a time. And you imagine having to iterate to that and waiting 16 seconds just to do this one little thing. And this is like a contrived example, but like Kotlin C is not much faster than that if you have like a sizable project. And it's a painful iteration time, so you really don't want to do that. There are ways to make tasks parallel. There's a parallel flag that will enable tasks to be parallel between projects. So if you have project foo and project bar, they will run them at the same time, which is awesome. Like that's a good first step. There's workers API that Gradle has introduced that allows you to shape your tasks in a way that Gradle can assure that your inputs and outputs are not going to overlap, and you can run them in parallel. But that's a lot of work. And then two, you can't change third-party plugins, right? Like a good example is Gradle's own Java plugin does not use worker API for Java compile tasks. That means you can never run 2 Java compile tasks at the same time by default, the default settings of Gradle, which is, to me it's wild. Like, why didn't they do this? That would be nice. The nice thing is the configuration cache. When they worked on this feature, they enabled additional constraints on your project that can ensure for Gradle that they can execute all of your tasks in parallel. Because they're able to serialize all of the inputs and deserialize them, they can execute all the tasks at once within project and between projects. And that's like huge gains, right? So if we look at the example that I did before, we go from 6 seconds of running something, or 16 seconds of running something to 6, right? And that's like a massive boost, right? And this is, again, contrived example, but like take any project, you will have tasks that you want to run in parallel. So like even all of the things aside of like, oh, I'm saving configuration phase time, like you actually want this, right? You want to be more parallel. And so that's kind of what you get. And the nice thing about this, you get the parallelism with cache misses in configuration or cache hits. It does the same thing every time. So you get the benefit, all the time. So even if you like do a real bad job and your configuration misses all the time, you're still getting the benefit here, which is great. Yeah, so hopefully you're motivated. You're like, oh yeah, I'm pumped. I want to do this. This is awesome. But let's talk a little bit of how it works. So you can kind of be like, oh, like it's not magic, How does it work? So if we take a very basic task, this is a task that takes a string input and an input file and reads them and then squishes and writes them into an output file. So nothing too wild, pretty basic Gradle. We go and register one of these tasks. We set an input, we set the files, and then we just register and it's configured. Then you run the task executes and it does the thing you want to do. It will create the configuration cache under your project root directory, and in there you'll file a couple of binary files. And then the second time you execute Gradle, you skip configuration phase altogether, and it's just like all amazing magic. It just works. And you're like, oh yeah, we're done. Let's run. Luckily, you can actually introspect it, so it doesn't have to be magic. So Gradle has created a tool called GCC to speedscope. Naming, not Gradle's best trait there. GCC does not stand for a compiler. It stands for Gradle configuration cache. It converts Gradle debug output into speedscope files. A speedscope, if you've used it, essentially is a way to look at flame graphs. And so what it does, it parses that information from your build, and it generates a speedscope file that lets you introspect of what's inside of your configuration cache. So you'll see this giant file. Don't try to read it. Speedscope is a little annoying for presentations because you can't make fonts bigger. If you hit Control-P, it just disappears, which is great. But if we zoom in a little bit and add some arrows, hopefully it makes it a little bit easier. It actually records everything we just talked about, right? It takes the input file, it puts an entry for the input file. It has the input, it puts the input file in there as well. One thing to note here though, because of how we're putting the file input, is actually not taking the contents of the file and putting in the configuration cache. It's just taking a reference on disk of where the file is, so then later it can recall it without having to run any configuration. And then so that's what allows Gradle to kind of do this. It does the same thing for output file. So it knows exactly where the output file is. There's an entry for it. And if you kind of look back, like all of these things, Gradle has kind of created types to convert and store serialized versions of them. And there's like stuff you didn't put, but it's there, right? There's task name. Gradle needs to know it, so you could like call task.name during task itself. So it stores that. You also need to know what class the type is, or what class type the task is, so you're actually able to execute it, and also which method you want to call, because that information is all gone if you're not running a configuration phase. So like it stores all of that, even though you didn't ask for it. It needs to know that, and it stores it for you. So no magic, yay! Gradle serializes it to disk. We can skip configuration phase altogether because it has all the data. And my task essentially becomes like it has no overhead. You're just doing the thing you want. You change the input file, and then out the output file is just runs, and it happens, and it's awesome. Yeah. And then the nice thing is, unless you change the inputs to the task, like literally the string, and you go modify build.gradle file, or you say you want to use the different file for the input, there will be no configuration cache invalidations, right? So like you're just getting all these nice benefits. It's great. If only it was that easy, right? Like, is anything in Gradle easy? So this is like another example where it's actually not that easy, right? Most builds, if you turn on configuration cache on, it will just fail. It will not work out of the box. So I will walk you a little bit through of like, well, what is the path to actually getting there? You probably want to enable the warn mode as a first step, right? Like most likely you have the invalid things you do, and you can just say Gradle like, actually ignore those things if you find them. And the way it works, it will store a configuration cache if the task you called has no issues. So if you find a task that like there's a specific flows and a specific project that just works, it will start working and you're getting like kind of the benefits of configuration cache. If it doesn't work, it will find some violations and it will be like, sorry, I can't use that, so I'm going to drop it on the floor, and then it will run configuration phase every time. The other thing you probably want to do is you probably want to upgrade all of your Gradle plugins. Most of them that at least are widely used in the industry, they've been like yelled at by the community to make configuration cache work. And if they haven't done that, you should go and yell at them. And then once you upgrade, a lot of the issues in your report will go away. And then finally, you want to fix your own build logic, and that's kind of what we will chat about a little bit. So we'll want to kind of walk you through some examples of possible issues you might have and how do you go about fixing them. So one very common thing you might want to do is you want to have a custom type for your task. You take let's say a class, and a class has a text and a number, and you want to use that as your input. And it worked just fine when you had configuration cache off. Like there was no issues. This code executed and it did exactly what you expect. But if you try to run it with configuration cache on, you'll be like, I don't know how to serialize this. And the reason is Gradle needs to know what to put on disk and how to restore it. Otherwise, it cannot run that task without running configuration phase. So essentially, what you need to do is you want to teach Gradle how to do that. For simple classes, you can just add serializable. Mission accomplished, done. For stuff that's more complex, you might need to use other tools like Kotlin X serialization or some other methods that store exactly what you need. Some of your classes might be super complex and store like oodles and oodles of data that you only really need for initialization or some other state. You have to essentially pick and choose what you need there. And if you look at SpeedScope, the file, like the custom made serializer that I wrote by writing :serializable, like all of that stuff now shows up in SpeedScope. So you actually see those, it's not magic again. Like there is, Gradle just takes it, serializes it to disk, and it's on disk. And now it can load it, when you run the task a second time. Another thing that's fairly common in your build logic, you might have a dynamic logic based if the input is present. So you can be like, if this file is here, use this one as the input. If it's not, use this other thing. And this pattern, kind of works, and without configuration cache on, you just run it and it works and it does exactly what you expect. However, if you have configuration cache on and the file gets created, now you just invalidated your configuration cache, and you're like, well, that's weird. Why would it do that? But the problem is like Gradle knows that it's a potential input to how tasks are created, right? You might even get a different task, you might have different inputs and so on. And so Gradle does the thing that is safe, and it just drops the configuration cache entry and then builds it from scratch again. And you want to avoid that because if you have a project that takes 40 seconds to configure, now you just forced your developer to go and do 40 seconds of configuration because they created a file. Luckily for us, Gradle has a configuration cache report that tells you everything that is an input to your configuration cache. So you will report the things that is considered as input, and if any of them change, it will go and nuke the configuration cache entry for you. This has most of the inputs, and we'll get to the most part at the end of the presentation. But like you kind of mostly can look at it, in our example here, primary txt is a system entry type input, which that means if it disappears or appears, Gradle will care about it and it will use that as an input. And it will affect the configuration cache hit or miss. And you can find this report in root project reports, configuration cache, random hash string, configuration cache report. Yeah, and then these things, they're not magic. Again, it's stored in the same binary files that I mentioned before. It will have a file system input entry, and that's how it knows that file is important. It will read that part of the configuration cache and be like, this file appeared now. I can't use this anymore, and then it can drop it on the floor. It is a very, very common problem. We saw lots of plugins mess it up because it used to work just fine, and you're like just checking if this file exists. How bad can it be? It was very common. So Android Gradle plugin had issues, Kotlin Gradle plugin had issues, we had our own issues. And most likely your plugin also has issues like that if you've not done this work before. There's some alternatives. Odds are some of these things are because you forgot to set up task dependencies. Like one task goes, creates an input, and then the other one reads it, and you didn't set up the connection, and it just worked because of the timing of how you had it set up. You probably want to have like proper tasks set up there. And then, so because what happens otherwise, you're just running a second run, and then you're like rerunning configuration phase, even though you shouldn't. So the other thing that is nice, you can just use input file and then mark it optional. So you take both the primary and secondary, and then inside of your task execution, you can decide like, I actually want to use this one or that one, depending on which one's available. And what that allows you to do now, if a file appears or disappears, there is no configuration cache invalidation. You just get all of the goodness without any like badness of it. The next thing is probably more awful, and you probably shouldn't have done it before, but you could read the file input or file content during configuration phase. And this Kotlin makes it super easy because you can just do .read text. It looks so nice, so easy, so quick. I've just read the text. One is like awful. You might just use a shit ton of memory. You might just be causing yourself like memory spikes because you're doing all of this stuff. And then even worse, you might have not even used this task. You might have not run it, and you did all this work during the configuration. With no configuration cache on, it's not going to complain. It will just let you do this, and it's great. But if you enable configuration cache, any changes to the inputs of that file will invalidate your configuration phase. And if you have a task that's frequently run, like let's say compile, lint, anything like that, you're like running configuration phase every time someone changes a file somewhere. And it's like awful, awful, awful. Like, don't do this. Again, this shows up in the report in an under slightly different section. That is, this one just shows input.txt under file, and file is the part where Gradle's like, oh, you actually care about the contents of it, so I will consider all of these. And TOML files by default are read during configuration phase, so they can generate libs.foo bar, so you can access those things. So like Gradle already treats its own things as the configuration cache input. So if you ever change TOML file, you will know now why the configuration cache is invalidated, because Gradle reads it and it cares about its contents, and it knows it cannot trust the evaluation that just happened. Cool. And the nice thing is also it tells you where you made your mistake, build.gradle.kts. It's not great, like it doesn't give you a full stack, but at least it gives you a starting point of where to find it. And then what are alternatives? Well, don't read it during configuration phase is the main thing, but you can use the file contents provider if you're lazy. Gradle will essentially read it for you, read a file for you on demand. It just wraps it and then does it lazily when you need it, or you can just declare it as an input file and then read it during the task execution, which is probably the preferred way anyway. Another thing you might have used is init scripts. Don't. Init scripts are awful and you should never use them, but if you put a new one in, it will invalidate configuration cache. People try to use it for clever ways of making your build behave differently, and there's better ways to do it. You might want to have properties, you might want to have other mechanisms. In general, it's not great. Don't do it, but it's also extra bad with configuration cache enabled. Where did we see this? IntelliJ, in fact, used to use this to run tests. So when you went and clicked on a button, I want to run this method in test, it created an init script, passed it to Gradle, and then used that to pick which test to run. It would essentially generate a file that had like a name of it method that you want to run, and it would pass it in that way. And what it did, it invalidated configuration cache every time you switch tests. You're like, I want to run this test method, and then configuration cache is blown off every time. Luckily, they fixed it since, but this is the kind of thing you want to watch out for and not do. Another thing you might see is environmental variables. If you go and read it during configuration phase again, now this is becoming part of your input. And what that means in configuration, without configuration cache on, this is fine, it works, there's no issues. But if you have configuration cache on and you change the value of that environmental variable, now you're invalidating your configuration phase. Not great, it's not really something you want to do. Again, the report shows it, so you can find it and you can see where it's set. It's also visible in speed scope the same way as all the other inputs. So you can probably hopefully getting the pattern. Using a provider is what you want. Same thing as the previous thing. If you read it lazily through a provider, Gradle knows it's not part of the configuration phase. It's part of the task execution, and then it knows that if you change the value of this, I don't have to invalidate all of your task graph. Same system properties, same deal. If you read it during configuration, you might start seeing the pattern here. If you change the value of it, it invalidates, not great, you don't want to do that. It shows up in the report. Again, you can look at it and figure it out. You want to avoid that, and because the more things you have in here, the more chance it is that someone will change something and that invalidates your configuration. And then reading is the same fix. Invalidation, it doesn't happen anymore if you read it that way. We actually saw a really nasty one where we're using SPDX plugin for our compliance for our build chain security, and this plugin was reading every single system property. And it was extra bad for us because Kotlin, when it does incremental compilation, it stores a system property for itself for the next compilation. And it changes from the first run of the incremental build to the second run. And that means every time Kotlin did this and this plugin was applied, we were invalidating configuration cache phase, no matter which property. And then when we filed the bug to them, they're like, oh, actually, we only need 2 of these properties. And they fixed that, and it was great. But up until then, they were reading everything, and then Gradle's like, well, I guess this is an input, so everything is an input. And then if it changes, the other thing to notice is Gradle properties is the thing that Gradle created for itself. And this is going to be a little bit of Gradle bashing here. But any change to any Gradle property will give you a configuration cache miss. Why did they do this? It's a good question. But if you'll change any property anywhere, it will invalidate your configuration cache. Use environmental variables instead is what we do, because that way at least the value doesn't affect your stuff. We filed a bug to Gradle to not do this. They should really track properly what the inputs are so they don't do this. And then long term you'll want to use a provider once they fix the bug. But for now just don't if you can avoid it. I mean, sometimes you don't have a choice, but in general you should avoid it. All right, now we're getting into a more juicy, interesting example, which is a little bit less obvious of what's going on. So let's kind of take a second to read through what's here. But what we have is we have a task that takes a list of files as an input. Nothing weird here, seems reasonable. And now when we are registering these tasks, we're creating an object called file tree. This is our standard Gradle so far. And then we take the files and then we sort them by name, for example. Or we could do files.filter by, and then by some sort of pattern. And what this does is essentially iterates through these files and then changes the order of them before we set them. And before configuration cache enabled, there's not an issue here. It works just fine. But what happens if you change the contents of that directory now, you will get a super unhelpful message from Gradle that will tell you something changed. At least it tells you which file. There are cases where it doesn't, and we'll talk about that in a second, but it's really unclear how to proceed. Like, what did I do to cause Gradle to be unhappy with me? Like, it gives you nothing. And you're like, okay, Aurimas keeps telling me there's a configuration cache report. I'm going to look at it. I'm going to know exactly what's happened here. And Gradle lies to you, and it does not show you that it has any inputs, right? This project shows that it only reads the TOML file and nothing else, but it is in fact invalidating a configuration cache. So something is being read and something is used as an input, but it's not reading, it's not telling you anything about it. So how do we find out what is invalidated? And here's where I walk you through the process of a debugger. So you find the line that Gradle prints. Says input to blah, blah, blah has changed, and you put a breakpoint there because that's the only way for us to have the information, and you can see what to do is Gradle says, oh yeah, we should really summarize this and tell people what happened, but they have not done it and it's been there for 4 years. So yeah, hopefully one day we'll do that. But you put a breakpoint there, and if you didn't know, you can breakpoint on Gradle tasks in IntelliJ or Studio, wherever you're using. You simply create a debug configuration, you specify what task you want to run, and then you can just tap the little debug button, and any breakpoint you already have in IntelliJ will just break on that. So super helpful for debugging stuff. Don't do print line debugging. Gradle use this way better. And so when you have a debugger attached and we start looking at it, we can actually look at the system inputs property that was on the stack there, and then we see like, oh, it's these mydir properties, and it kind of tells you what is new this time compared to the last run. It doesn't tell you what the last run inputs were, but it tells you the new inputs. So it doesn't quite give you the full answer, but like now it gives you a hint, like where could have messed up, like where are we doing it wrong? So you will note MITR in here, and that's kind of what you want to take out of this step. And then we need another Gradle breakpoint where we try to capture where are these file collections being collected. So that way we can know when Gradle adds it to the input, we can compare, and we can essentially see on that breakpoint observe where it becomes a configuration input. If it's a large project, you might have a bad time on that breakpoint. So consider conditional breakpoints, because that way you can skip the stuff that doesn't make sense. But once you get to the right thing, we see like, oh, there's a directory called MITR, and it tells you that's the one that's the input. And now you can kind of like in your head connect like, oh yeah, that's the part that changed and validated, and this is the part that's an input. And so now you can do the connection. And luckily, because you can remember in the warning, it told you it's build.gradle.kts that caused or had the input. You can kind of walk through the stack and find the mangled version of build_Gradle, and it'll point you to the line exactly where it became an input. So that's great. Aha, we found it. This is great. But like it can kind of show you that some stuff in Gradle, a lot of them are good, but there's still some rough edges where you might have to jump in a debugger and actually look for the stuff where it's hidden away. It might not be obvious. But here we found it. We hit this in Android Gradle plugin. It was doing that somewhere inside of Android Gradle plugin. And it's not helpful, right? You get this message and you're like, oh, okay, so what happened there? I don't know. So it's extra painful when it's a third-party plugin because you don't know their source code, you don't understand why they have done it one way or the other. It's extra bad if it's an obfuscated plugin. So if you're pulling in a plugin from someone who is evil and then they don't want you to know what the implementation is, you can't even feasibly figure it out. So you're probably going to have to file a bug and a repro and then be like, here's what's happening. In this case, we were able to find, and in fact, Studio was doing an iteration on the task graph or on a file tree that was causing this invalidation. So what's the alternative is traverse the files during the task execution, not in a configuration phase, or you can use a file collection with filters because file collections can be lazy depending on how you set them up. And then there's also that bug to Gradle that someone in the audience has filed to make it so Gradle doesn't give you useless warnings for this type of case. Yeah. Okay, so that's a lot of work. We spent a lot of time doing this. What's up to that? So in Android X adoption, the way we approached it is we really prioritized most common tasks first. So we found that compile flow and test running flow is the one that like everyone runs all the time. So we enabled it to the warn mode, and we just kept iterating and getting closer and closer to being hitting configuration cache entries every time, and that kind of unblocks the main benefit. And once you have that in there, then you work your way through a slew of other problems. And for us, it took many months to get from warn to error. It was a pretty miserable process because some of these things are like really deep in the weeds that you have to navigate through. But once you get to it, you can enforce it that no new things appear. And in the process, we reported and helped fix dozens of bugs in Gradle, in Android Gradle plugin, and Kotlin plugin, Protobuf plugin, SPDX plugin. I think there's probably a few other ones that we missed, but it was a lot of work, and we had to fix dozens of issues in our own logic. So the old way of Gradle, which is not deprecated and still works, is sometimes not good. So you have to go and migrate to the new way of Gradle that's not documented and not explained anywhere. But once you do, it works. So that's nice. And then the final annoying thing is upgrades can still bring in regressions. So if you try to upgrade to Kotlin Gradle plugin 2.0 and you use Kotlin multi-platform, you might have not noticed, but they sneaked in a couple of invalidations for configuration cache. Specifically for Android X, we are so what's the right word, cautious, that we try to set up our build to validate that, in fact, none of this happens. So what we do is we have a runner in our CI that takes our build, runs it first time, and then it runs it the second time, and then ensures that no tasks ran again, and then we hit configuration cache. So that way, at least for the very basic thing of like, if I ran the whole build and I ran it again, where did it go? So this system that we call task up-to-date validation essentially allows us to catch bugs in third-party plugins and our own logic, where if we accidentally make a mistake, we have this backup net to catch us. And this is kind of how we caught it. We tried to upgrade to the new version of Kotlin Gradle plugin, and we're like, oh, actually, we can't. It has bugs. So you report it to the authors of the plugin, and hopefully you help them fix it if you have the skills. If not, you wait and complain and squeak. But please do complain. And you're like, oh, Aurimas just said, oh, Android X is perfect. We're not. If you look at our report, we have no problems, but we have thousands of inputs. And any change to any of these files, system properties, environmental variables, will invalidate our build cache. Or, it's not build cache, ooh, that would be terrible, configuration cache. And that essentially is not great, right? And so we're still working our way through it. Some of this stuff comes from plugins that we don't have a lot of control over. Sometimes it comes from the fact that a plugin is using a library that's doing system property reads. Like sometimes it's really difficult to fix, but we're still trying to dial this down. To prevent regressions, we filed 2 feature requests to Gradle, which one would be nice to know a list of all of your current inputs to your configuration phase, so you could actually store it and then compare that no new ones appear. Do subscribe to both of these, I would appreciate that. And then the second one is, wouldn't it be nice if you could assert that configuration cache was hit? Currently, there's not a way without reading logs and doing some little string parsing to do this. It would be nice to assure that. So some takeaways: use progressive adoption, especially for like compile, test, like very common iteration loops. Once you get it working, you're not going to want to go back. Like me having to enable it for the slides and waiting for 40 seconds and recording it, I hated it. It was terrible. And once you enable it, and if you have it in the CI as well, you probably want to store the configuration cache reports so you can go and introspect. So if you accidentally introduce a new input, it's so nice to be able to go like 20 builds back, like, oh, when did this input become an input? So that has been like saving us a lot too, like we've been storing that. Additionally, you really want to bring that report down to a minimal set. For a hello world, you can bring it to a 1 file, but in reality, it's thousands. But the more you bring it down, the easier and the more frequently you're going to hit your configuration cache hits. And then the nice thing, or the interesting thing, is once you're not having a configuration phase getting in your way, you start noticing all the other things that are slow. So, for example, compile Kotlin is pretty darn slow once your configuration cache is fast and it's hitting it all the time. And so that's why you might want to upgrade to Kotlin 2.0, right? Because they fixed some improvements in there. But like essentially what it allows you to do is instead of focusing the thing that's like the long tail, now you have the next thing that is the problem. And it's kind of like the nice thing about like, oh, like now we fixed this one area, like let's focus on something else. And then the sad news is that, your Gradle sync is probably slow today. If you click on it and it takes minutes, it's going to continue to take that time because configuration cache is built specifically for serializing task information. And the Android Studio and IntelliJ, what they do is they actually call for information in a modeling system, which doesn't have an equivalent of serialization method. So your Studio sync will continue to be slow. Alrighty, this is a picture of my dog, Billy. Yeah, if you have any questions, now's the time. I have like whole 3 minutes for you to ask me questions.